MACHHOLZ, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 40 for the week of October 7th, 2020, my birthday. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on October 7th, the moon is 70% full in the morning sky, rising about 3 hours after evening twilight. By the end of the week, Tuesday, October 13th, the moon will be a thin crescent in the morning sky. That gives us plenty of time to observe those objects in the evening sky, and there is plenty to see. The summer Milky Way, beginning with Scorpius, is in our southwest. By this time next month, it will have disappeared into the sunset. The open clusters, globular clusters, and nebula in Sagittarius, and even south of Sagittarius for our southern hemisphere friends, and stretching up through Cassiopeia are begging attention. And you even have the Andromeda Galaxy up in the northeast for those in the northern hemisphere. Get them before they're gone for another 6 months. But wait, this time of year, those objects are always there. This year we have some sensational planets, the best our solar system has to offer. Jupiter and Saturn are both in our southern evening sky. We have been watching the spacing of these two giants, and now they are beginning to close in as we witness the chase of the planets. As our week starts, they are 7 degrees apart. In 1 month, they'll be 4.5 degrees apart, with Jupiter moving eastward in relation to Saturn. By December 21st, they will be within 7 arc minutes of each other. That's 1/9 of a degree, close enough to fit in any eyepiece field or CCD chip. They will be closer to the sun as seen from the Earth by then, so find a place with a good southwestern horizon for that event. Both Jupiter and Saturn are amazing objects through any telescopes, well worth the time. They are ever-changing, especially so with the atmosphere and moons of Jupiter. Tired of seeing Jupiter and Saturn? Try Mars. The planet Mars was closest to us on October 6th, and it will reach opposition on October 13th. Through a telescope, it can be a fine sight, 22 arcseconds in size. It won't be this large again for 13 years. You see, Mars and the Earth, that is us, each orbit the sun. We have the inside track on Mars, and we travel faster than Mars around the sun. Every 2.2 years, we overtake Mars. It passes through opposition. That is when we are between it and the sun, and it is opposite the sun in our sky, rising when the sun sets and setting when the sun rises. But Mars does not have a perfectly round orbit. Sometimes it is closer to the sun and to us than at other times. Last time at opposition in late July 2018, it was 3 million miles closer to us and 24 arcseconds in size, compared to the 22 arcseconds we now have. The time before, it was 18 arcseconds in size. 22 arcseconds is more than half the size that Jupiter is at this time. Now, the Mars oppositions, when it is closest to the sun and produce the largest images, They occur when it is in our southern hemisphere. So the southern hemisphere observers south of the equator have Mars very high in their sky during the most favorable oppositions. This week, Mars is 5 degrees north of the equator and 22 arc seconds in size, probably the best we'll get from Mars in the northern hemisphere for at least a decade. From this time forward, Mars will linger in our evening sky as we leave it behind. It will get smaller and dimmer. At the end of this year, 2020, it will be half the size it is now. By late June of next year, it finally sinks into the evening twilight as it goes around the far side of the sun. So much for the location of the planet. Now let's get down to observing it. Do you want the good news or the bad news first? Okay, the bad news. Over the past few decades, we would hold public star parties to observe Mars at each opposition. They were called Mars Watch, and hundreds of people would turn out. This year, due to the virus, there'll probably be very few of those. Anyway, us amateurs would turn our telescopes on Mars and let the people look. A lot of disappointment. The real view was generally well below the expectations. Now, some of that cannot be helped. Mars does get a lot of hype. Additionally, the average person is not experienced in picking up detail through an eyepiece. And Mars has less contrast than what is expected. And many people see an orange, yellow, or red ball, a tiny ball. We would always have a few telescopes on other targets besides Mars. This year, Jupiter and Saturn provide a nice backup. The good news. To see Mars well, you have to look at it for a long time, not just a peek. The more you look, the more you'll see. For one thing, our atmosphere is not steady, and you will have moments, sometimes lasting a fraction of a second, when detail will appear briefly. Keep watching. It will happen again. So get comfortable at the eyepiece and watch Mars for even 10 or 15 minutes. Then come back an hour later. Perhaps the atmosphere is better. And try again the next night. With practice, you will get better. Now, what can you see? The light and dark markings of the planet? The polar cap? The moons of Mars? All can be and have been seen from the Earth. You can too. It just takes patience and time. And in the evening sky, we have one comet. And the morning sky has at least one more, and we'll cover those comets later. The Crescent Moon passes about 4 degrees north of the bright planet Venus early on October 14th. This is a good photo opportunity. Last week, I suggested we all look at the full or near full moon for a complete 20 minutes and look for birds flying across the silhouette of the bright moon. I did that with 40 by 100 binoculars on the bino chair, and in 20 minutes I saw 5 birds, 4 flying south and 1 flying north. We'll do this again in a few weeks. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, October 7th and runs through Tuesday, October 13th? It all depends upon where you live. This week, we have 5 zones. For those living north of 50 degrees north, there'll be no visible passes of the ISS this week. Greenland, Finland, not this week. Between 15 and 50 degrees north, the ISS will be in your evening sky, but only for the first few days of the week. Most of Europe and the USA, that is you. Between 15 degrees south and 15 degrees north, the equatorial zone, The International Space Station will be visible in your evening sky during the second part of the week only. Central America, evening skies late in the week. Between 15 and 40 degrees south, you can see it in your morning sky, but only for the second half of the week. Most of South America, now that is you. South of 40 degrees south, the ISS can be seen in your morning sky, sometimes twice per morning. New Zealand, once again, you win. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. For the past 5 weeks, I've been discussing my book, A Decade of Comets. I wrote this in 1985 as a study of the 33 comets visually discovered from 1975, which was when I began comet hunting, through 1984. You did not ask to join a book club, but hey, the book is free and can be downloaded from my website in sections. This week, download Podcast 40, A Decade of Comets, Part 3. Now, this is the same download we had last week, so if you got it last week, you could use it again this week. Part 3 is the time of the discoveries. Last week, I covered the first part of Part 3, such as the number of discoveries each year and each month, and the number of discoveries from each hemisphere throughout the year. Now that is Podcast 39 in case you missed it. Podcast 39 also has a handout covering all 94 comets visually discovered since 1975, with 61 new ones not covered in the book. The phase of the moon is very important for comet hunting. Generally, comet hunters do not sweep the heavens when a bright moon is in the sky. A study I just did of Charles Messier's discoveries shows that he avoided the moon too. If not for the moon phase, I have often thought that visual comet hunters would eventually go insane, or more insane, as every clear night would afford an opportunity for dusk to dawn comet hunting, and some would take advantage of that. The moon phase modifies a comet hunter's sweeping schedule. Now, comet hunting is not scheduled like deciding when to go see the latest movie. For instance, if I don't see that movie tonight, I can see it this weekend or next week. Not so with comet hunting. Potential comets are moving slowly across the sky and brightening. And amateur astronomers and now professional surveys are always out there looking. Here is a truth I learned about comet hunting that I thought I knew well, but experienced the pain of relearning it as some of those comets were discovered in 1975. And that is, anyone can discover a comet in any part of the sky at any time. Yes, that can still happen, but there are trends, and this study did bring out those trends. Way back in podcast 6, I discussed my comet hunting theory, and now would be a good time to present it again. It matters here. Refer to podcast 6 for detailed discussions of the comet hunting theory with examples. After I began comet hunting in early 1975, I studied the comets that I had missed discovering and determined that several factors prevented me from discovering those comets. By about 1976 or 77, I determined that 3 factors must take place in order to discover a comet. If you did all 3, you would find a comet, assuming there was a comet available. I had to work in getting better in each of these three areas. For each comet that I missed, it was usually only one or two of these conditions or factors in which I failed. The first factor is position. You must be looking at the comet. Yeah, real funny but true. There are 41,253 square degrees in the sky. Where are you going to look tonight? Where would a new comet most likely be lurking? We have briefly discussed morning and evening sky, northern and southern parts of the sky. We will discuss this in more detail in part 4 of A Decade of Comets. Second is brightness. The comet must be bright enough for you to see it. As we studied part 2, the individual comet discoveries, you heard stories of how some comet hunters missed discovering comets because they were too faint. Later, after the comet brightened a bit, someone else would come along and find it. There is a trade-off in comet hunting, and I did discuss that in podcast 7. This is the different types of comet hunting. Suffice to say, you can cover a lot of sky or see very faint objects, but not both. The third factor required to discover a comet is timing. You must find the comet before others do. Up to 3 names can be on a comet, and after the first person finds it, typically, and this is not a hard and fast rule, but in the 1970s and 80s, the door would remain open for another 24 hours to see if anyone else would find it. More recently, a suspected comet can be placed on the Near-Earth Asteroid Suspect page with a date of observation, position, and brightness for everyone to see. When that happens, it becomes difficult for others to later prove they independently found it. And once a comet is discovered and named, you cannot discover that comet. So, in a sense, we compete with each other to find a limited number of comets. We compete, but that does not mean we're not friendly towards each other, in part because we share the same quest and we are part of a small worldwide group of comet hunters. So the 3 factors that must be met to find a comet: look in the right place, see faint enough to see the comet, and find it before others, kind of like the 4 dimensions. Now, this timing thing, that is where the moon's phase comes into play. Let's pretend the full moon is tonight. No one is likely to be out comet hunting because the bright moon will wash out the sky and reduce contrast, making it difficult to see extended objects. Tomorrow night, the moon rises 40 minutes after sunset while we still have twilight, and the moon is still bright, so again, no comet hunting. 3 nights from now, the moon rises 2 hours after sunset, giving under an hour of dark sky. That is when the comet hunters hit the evening sky. The next night, they get an additional 40 minutes as the moon rises 40 minutes later each night, more or less, and so on. 1 week from today, when the moon is at third quarter, half full in the morning sky, much of the evening sky can be covered, and the moon rises around midnight. The evening sky remains moonless for another full week. Comet hunters who have had bad weather earlier can sweep the evening sky, but others might have already covered it. The evening sky remains huntable after the moon reaches new and enters the evening sky as a thin crescent. So we have about 15 to 17 evenings available for comet hunting each month, and this is dependent upon the moon's phases and positions. Now let's look at the morning sky. This is where the action is. Comets move 3 times faster and brighten more rapidly in the morning sky than they do in the evening sky. Dr. Everhart's 1967 study showed us that about 75% of all comets first become discoverable in the morning sky. 20 of the 33 comets studied in a decade of comets were found in the morning sky. That's 61%. The morning sky was a hot spot of visual comet discovery. In the morning sky, in the nights after full moon, the moon diminishes in size and brightness each night, but it is illuminating the morning sky. Around third quarter, it's rising about midnight and is 50% full. So how much moon can a comet hunter tolerate? It depends. When I started, I set the cutoff at about 33%. If the moon was greater than 33% full, I generally did not comet hunt. I modified this over time, and this is how I did it. My evening sessions, which numbered fewer than morning sessions, would often last until moonrise, perhaps 2 or 3 hours or even longer after evening twilight. Frequently, and I wasn't the only comet hunter doing this, I would swing over to the eastern horizon on the final hour of darkness before moonrise and hunt what was technically the morning sky, although it was at long elongation, far from the sun. Then the moon would rise and the dimmer galaxies would start to disappear. I recorded what I could see and not see under various lunar conditions. Through experimentation, I realized that I could comet hunt when the moon was as much as 40% full without losing more than a magnitude. But that depends. Elevation gets you above some of the atmosphere and dust. I was at 3,300 feet at Loma Prieta. That's about 1,000 meters high. Also, I generally look away from the moon. If the moon was rising in the southern sky, I would sweep north or vice versa. So many of the comet hunters wait until the moon is a crescent of some percentage in the morning sky before comet hunting. The morning sky is then huntable for the next few days when the moon becomes new. Then, as the moon moves into the evening sky, the morning sky remains dark until a few days before full moon. At that time, the bright moon sets in the western sky in the morning, an hour or two before morning twilight. Comet hunters still get out at this time, as some would sweep the same areas we had covered the previous 2 weeks because things happen quickly in the morning sky. And those who had bad weather will go out, but they are late to the game, so to speak. But this last stretch before full moon has worked well for me for some of my visual comet discoveries. Figure 2, page 61 of A Decade of Comets, free handout this week from my website, shows the moon phases for comet discoveries. The 20 morning comet discoveries start 5 days after full moon. 6 of the 20 comets were found before full moon. A spike of 4 comet discoveries occurs the day after first quarter. 4 days before full moon, the morning comet discoveries stop. As for the evening comet discoveries, we have 2 peaks for the 13 comets, one beginning 4 days after full moon, and this one lasts 4 days, then again just before new moon. I also looked at the day of the week for comet discoveries. Some of the 33 comets were found by more than one observer, and occasionally, for instance, one discoverer would find it on a Tuesday night, and the next discoverer of the same comet would find it on Wednesday night. So here we look not just at 33 data points, but 45 data points for the 45 discovery events with those 33 comets. Monday morning is the most active. in part due to the October 5th, 1975 discovery of two comets bearing 6 names by Japanese comet hunters. Friday morning had no discoveries in this sample, but in the years since it has been represented. Next, we're going to consider this. In the evening sky, how soon after sunset you start comet hunting? Okay, so the sun sinks below the horizon. A study I did in 1980 shows how the twilight sky develops. Darkness descends from well above the horizon to the horizon, and finally the sky is more or less dark all the way to the horizon around the time of astronomical twilight. That is determined when the sun is 18 degrees below the horizon. Now, why does this matter? Comets are generally brighter when near the sun, and this part of the sky sets around the time the sun sets. A small elongation, that is a number of degrees between the sun and the comet, is what we're going for here. And with each passing minute after sunset, as the sun sinks lower and lower below the horizon, it pulls any comets with small elongation down with it. If you start sweeping too soon, the sky will be so bright you'll not see much. Wait until the sky darkens more, and now the object is lower in the sky, lost in the haze. We all had to deal with that. Another study that I did is when I graphed the end of each comet hunting session with the sun's location, and it showed that I often swept until the sun was 15, not 18 degrees below the horizon. 15 degrees is what I consider my comet twilight, and it is about 15 minutes different than astronomical twilight. Figure 4 of A Decade of Comets, page 63, shows comet discovery times versus astronomical twilight. The morning sky discoveries begin 3 hours before astronomical twilight and continue until 40 minutes after astronomical twilight. The average time is 31 minutes before astronomical twilight. There is a sharp peak of comet discoveries, and that occurs 20 minutes before astronomical twilight. I have often wished in my fantasy world that the Earth would stop spinning about 10 minutes before morning astronomical twilight, so I could casually sweep the whole eastern sky. But it won't. Instead, the world keeps turning, and I have limited time to cover that most productive sky. Figure 5 shows the evening discoveries plotted against astronomical twilight. A few are found before then, while the sky still has some brightness, but the vast majority of the 13 comets were found within 1 hour after astronomical twilight. Next, we look at the date of the comet's perihelion. Now, that is when the comet is closest to the sun versus the discovery time. These are shown in figures 6 and 7. For comets found in both the morning and evening skies, those comets were generally discovered before coming to perihelion, as they were incoming, with the evening discoveries having a longer lead time before perihelion. Morning sky comets generally have more time to come to perihelion while still behind the sun, prior to discovery. Finally, we compare direct orbit comets, going around the sun in the same general direction as us, and retrograde orbit comets, they do the opposite, and their discovery dates versus perihelion. Retrograde comets tend to sneak in faster. Next week, we move to part 4 of A Decade of Comets. How bright are comets upon discovery, and where are they found in the sky? 2 very important questions for comet hunters. Now for the comets you can see this week. The positions, that is the right ascension and declination of these comets can be found on podcast 34, Comet Positions. Periodic comet Howl is in our evening sky. It is in the vicinity of globular cluster NGC 6355 on October 9th and 10th. Both are at about magnitude 8.5. Periodic comet Howl is plotted on podcast 40, map 1. Comet 2020 M3 Atlas is now about 9.5 magnitude and is brightening nicely in our morning southern sky. It is visible from both hemispheres. It's plotted on podcast 40, map 2. Our third comet is Comet 2020 P1 Neowise, not to be confused with the bright comet Neowise seen a few months ago, but this one is also in our morning southern sky. However, it's visible only from the southern hemisphere as it nears the sun. It is expected to brighten to magnitude 9 by late this week, but it will more and more appear close to the sun. The northern hemisphere will be able to see it in late October if the comet survives. Now for fun with the marathon. The Messe Marathon, the challenge to observe all 110 galaxies, clusters, and nebula that were cataloged by Charles Messier in one night, is best done in late March of each year. Then is when the sun and earth are so placed that from certain latitudes, all 110 Messe objects are visible in one night. But the Messe Marathon can be done any time of the year with various potential outcomes. This month, the new moon is October 16th, and the weekend when most marathons are done will be October 17th. What is the prospect for doing the Messe Marathon on October 17th? You will be very busy at the start of the night and very busy just before morning twilight. This month is one of the most difficult times to do the Messe Marathon. Are you up for the challenge? I've done a marathon twice in October, once in 2002. That was October 29th and 30th, and I saw 105 objects. And then again in 2008, October 25th and 26th, and again saw 105 objects. Both were done from Northern California, latitude 39 degrees north. Well, you begin with M5 in the twilight, then M80 and 4, with M4 being diffuse and blending into the evening twilight sky. One year I could not see M4 but was able to pick up M80. Continue through Scorpius, Sagittarius, Capricornus, then northward. You can ignore for now the stuff near the Big Dipper. You can get that in the morning. 2 hours after evening twilight, you will likely have found only 55 of the 110 objects. Now, if you picked up those northern objects near the Big Dipper, your number will be more like 70 objects. Still, these are relatively low numbers for our first 2 hours. The next few hours will see the Milky Way items rising. The rush begins in the final 90 minutes before dawn, when Leo and the Virgo galaxies rise. Don't panic. Go steady from one object to the next and you should be okay. The October Messe Marathon is one of the most difficult ones if you wish to see everything possible, but it is a challenge worth doing. You have been listening to Looking Up with Dawn, podcast episode 40 for October 7th, 2020, my birthday. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. That's where you get all the free handouts. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky and comet discovery data from the book A Decade of Comets. Just how bright does a comet need to be discovered? All that and more. Thank you for listening. See the sky this week. I'll see you next week.